test, as an exam. It will be
Okay,
online. You
assignment.
understand? As you are coming to my class, as the assignment that I am sending to you, it will be like this. I will put these PowerPoints on your screen, and you will do every question. Then I will go to the next. For every question, you will have probably 15 minutes. After you are finishing, you tell me that you finished, and I will go to the next question. You understand? Maximum 15 minutes for every question. Around six question will be. Is okay?
Okay, which chapters?
That we did already. The supply, demand, theory of demand, and utility that we are going to exercise today a little bit. Okay.
Okay.
If not, I will do after next week, because I want to do it early, as you don't enlarge and increase these topics. This will be maybe more easy for you to follow up. Then we will start to do the rest. Okay? Is here?
Yes.
You are. Yes. If you want, I can do 1 week later. You tell me, then I will do it.
Yeah.
Yes.
You know, during the classes, we had problem with your PowerPoint. Maybe the same thing will happen that week.
Tell me.
During our classes, we had a problem with your PowerPoint. So maybe we'll have the same problem in that week. So can you
No, no. For PowerPoints, I will always apply, quit and apply for every paper, every slide, because sometimes it is freezing because of the system. It is not moving easily, but last week it was moving, isn't it? It was moving, and we will see this week also. I don't think that it is a problem for you. If there is a problem, then we will find the solution.
Can we make it 9 from 9?
Can we make what?
From
at 9?
Yes, on Wednesday from 9 to 11, because I have class up from 12.
From 9 to 11?
Yeah.
I can do it, but if you want, I can do it later. I can do it after 2 or 3, as you wish.
No, we have.
If you have us, are you colleagues? Or you don't join every classes. You have to stay only for this at 10 to 11, 1 hour, 1.5, 11:30. Then you will join to the other, or you will request the PowerPoints from the other course instructor.
Okay.
No problem. I don't think it will be a problem, because if some start coming early, then it is a problem. Okay. Let me start to class. Okay.
Okay.
Is it okay? You have to inform Abdurrahman. Abdurrahman is online, I think. Abdurrahman is online now. Join us now. Abdurrahman Yebo. Yeah, we have next week on 10 on Wednesday at 10 a test. So you online, okay? You have to class. If you don't, then you miss 30 points, because it will be around 30 points. Is clear? Abdurrahman, is it clear? If you are not hearing me, you write me.
Please, easy
Tell me, Hatice.
Please, easy questions.
Easy question, of course. I do everything what we did.
Because we don't want DD. We want to pass very well.
Oh, I know. I will try to do my best. Don't worry. I am your side. I am on your side. What is it?
We want AA.
Okay. Oh, you all want I want also. Okay, let's start it, okay?
Okay.
Okay, hard. Okay, you are seeing now the class, the PowerPoints. I think you need, yes. I am in the first page, conferences and the concept of the utility. You are seeing the first page?
Yes.
Yes, you see, it's okay when not too too much students online. Okay, for the outline of this class, I have to give you information that I am going to give you the consumer preferences because we are in the micro demand side. We are always concentrating to the demand side, the consumer preferences, the consumer utility, how we are going to increase and enlarge the welfare of the um, consumer preferences and utility. As you know, it is one of the important problem in economics because we are not only concentrating to the profit or to the so-called supply side, but the demand side we are concentrating. Therefore, in micro, as you know, the demand is mostly concentrated to the preferences of the consumers and the utility function, which we are trying to increase and enlarge the satisfaction. And the indifference curve, the marginal rate of substitution and special function forms that we are going to exercise in this class. Okay, supply and demand models are useful for analyzing economic questions concerning market. How will increasing the real wage affecting output? And in these models, we assumed and we summarized as the individual's demand to obtain the market demand curve in this direction. But we want to know how to determine this demand capacity, how we are going to determine this welfare problem to increase and enlarge the consumers is in we need to individual and the consumer preferences and behavior, how is going to be enlarged and increase the welfare is in we are trying to enlarge is the utility. The individual test or preferences determine the amount of pleasure people derive from goods and services. This either. The consumer preferences faces some constraints, some budget constraints that we are exercising because, as you know, most of the consumers are between income wages or the salaries that they are going to holding in the hand, how they are going to this regarding to their preferences and needs. And the consumer maximize their well-being or pleasure from consumption subject to the constraint they face. You are observing and following this slide 4. Slide 4.
It's going good.
Description.
It's
If
going
you
good.
don't, then it's okay. You can download the PowerPoints and from there, or either is possible. The questions tell us the consumer would rank any two basket of goods, assuming these allotments were available to the consumer at no cost. And basket or bundle is a collection of things that an individual might consume. P Q plus P with Q multiplied is equal or is less than income that we are holding in the hands. This will be exercised in the following slides. When we are looking at the preferences, properties of these consumer preferences, we have some assumptions. The first assumption is directly related with the completeness of the consumer preferences. Either these preferences are complete if the consumer can rank any two basket of goods, because we're trying to analyze this in this aspect. A is supposed to be strictly preferred to B, then is supposed to be A is the, of course, element of B, and strictly preferred to B. If B is strictly preferred to A, then is B supposed to be element to A, then the difference between A and B can be illustrated as A is supposed to be equal or is somehow similar to B. The transitivity is the of this direction. Then sensitive if a consumer who prefer basket A to B or basket to C also prefer to be basket A C can be therefore A prefer to B and B prefer to A, then we may conclude that both A is also going to be instead to C can be replaced. The monotonic, it is supposed to share properties of the preferences, as monotonic is a basket with more of at least one of the original basket. Predisposal can be worse of more. The more is better assumption is also here real, also known as the property of non-stationary something went more off. And we are not looking at that in the pollution. We can assumptions to is as you are understanding is of course very important because at least one good and many good is preferred form. Here the preference is illustrated as you are observe pointed here A, B,
Am I the only one that can't hear anything?
No.
No, we also can't hear anything.
I think he left the class.
What's happening?
Maybe his internet or something.
What now? Hussein? Shall we text him?
I think like that because we are waiting him up to now and he's not coming back.
Yeah,
Let me
something
contact.
must have happened because he was explaining and then nothing.
Yeah, he used to do. He used to quit then come back, quit come back. Now he's not coming back.
I think he has internet issues. That's
Maybe,
why.
maybe.
Most probably, yeah.
now? Yes, I think you are hearing. Okay.
Yes.
Because I think somebody is also presenter here and it is pushing me out. I don't know who is this because you should only become as a participant, not presenter. If you press the presenter button, I will be pushed out. I will be excluded. Therefore, you should carefully follow this. Then I can join this meeting. I am the, of course, video presenter. Anyway, I will go further. Mm. Now the video is not coming. That's the problem. I have to close this one. I am downloading, opening this video again. Do you hear me? Yeah.
Yes.
Are you listening me? Shall I have to go on?
Yes, Hajam, we are hearing.
Okay.
Yes.
You able to see this? You are seeing PowerPoints, these slides?
No, 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 Hajam.
No, you are watching me only. Still not?
No,
No. It says you are seeing. Maybe you will see now. What about now?
not
You
yet.
see?
No, Hajam.
Not yet.
Yes, we can see now.
You are seeing, yes. Because system coming slowly, I think there is a problem with the game. Yes. Okay, let's go. I said to you, we have two different products, clothes and food, and the combination of this can be differently allocated as you are seeing on this graphic. And when we are looking to this intransitivity and age of any given combination, that is important for determining their preferences. It is supposed to be when the people ages differently realize their insensitive choices also changing regarding their age and the subject they are using. And when we are looking to the ordinal and cardinal ranking as we already done in our last lecture, is the information on how a consumer ranks different good, but does not say how much or how many, or how you are going to get. And cardinal ranking is the information on the intensity of the consumer preferences, as the basket uh, 10 times more than B, for example, the basket B. Therefore, this is somehow the comparison between two. The other one is only the ordering, and of course, the timing is subjected. We didn't do this class, isn't it? Students take an exam. After the exam, the students are ranked according to their performances. As ordinal ranking list, the students in order their performances. Harry did best, Joe did the second, Betty did the third, blah blah. It goes like this, and the cardinal gives the grade of the exam based on their numbering as a mathematical illustration. Harry got 50, Joe got 100, and Joe did the second best, second time better than Harry. We compare definitely and concretely and solidly. The utility function, as you know, is the measure of the level of satisfaction that the consumer receives any basket of goods. As you are understanding, utility function is equal to the given amount of product which is in the market, and it can be illustrated as the utility function is equal to the function of is in bracket x1, x2, x3. It goes to xn. There are many products which is in the market, and of course you are already ready to get any of these products regarding to your preferences and of course taste. And since it is concentrated to the ordinal and cardinal ranking, then you are, of course, again putting this into your list as the first runner, second runner, third runner, like this. Then you are ordering and, of course, counting your taste, your quality, and your other interest. The utility function is, of course, is the magnitude of utility have no interpretation as it is illustrated in the graphic as I have. So you can differently put this utility regarding to your preferences. It cannot be, of course, precisely illustrated as it is in the graphic shown. It is depending to you totally, your preferences, your capacity, your let's say capital amount, your income, everything is concentrated. Utility is not comparable across the individuals because you are alone, one person, and you have your own preferences, and every person has his own color, has his own taste or her taste and quality standards. Therefore, we are not able to compare and tell he is better or she is not good. Or every person has his own taste and, of course, preferences. Therefore, we are not able to compare everybody's preferences and judging regarding to their interest. Then utility function is illustrated as it is indicated on the graphic. You are observing utility function or seeing function. You see this? You are observing graphic?
Yes, yeah.
Okay, then
Yes.
we have here the consumption of muffins, of course, the utility which is going to offered with these muffins. As you know, muffins mostly, of course, dependent to the people who are, of course, like some sugar. And sometimes it cannot be directly related with people who are not preferring and buying this. But every product has his own utility standard, and it goes to the optimal points where here it is illustrated around 2, the total unit, sorry, total utility of muffins, and of course the consumption of muffins is directly parallelly related. And as much as you are shifting this to the maximum, the utility function will be realized as utility is the function of y power of 5 is the function is given in this example. Then you can use this as, of course, estimation and calculation for this given product. every product has its own utility function, utility equation. Therefore, we have this utility estimation regarding to these utility preferences and changes on time. And as much as you are increasing and enlarging your consumption, probably the utility will reach to the maximum points. And then after this, then it comes to the negative, or it is starting to reduce and become less and less. Therefore, we have to determine how much we have to consume and where you're going to consume it. The utility function is, of course, means after this explanation, there is marginal utility which is related to the every next utility changes that you are going to add to your basket will probably increase up to a limit, then you will have this maximum points. Therefore, the marginal utility can be defined as the rate at which the total utility changes as the level of consumption rises, and as much as you are increasing it, it is going to be smaller, and then you will then of course reaching to the optimal, then you will start to become negative or not tasting it anymore. This is something like that you are drinking water. The first drink is probably the maximum optimal utility offer to you. Then of course every next drink or eat will of course reduce your desire to eat or drink this is not thirsty anymore because you full up with water or you full up with let's say food. Then you have the maximum point and you say that okay, this is much for me, I don't want anymore. And if you are insisting to consume or eat or whatever it is, then it goes negative and it calls you negatively and of course reduces utility, and of course uh, differences will become into the negative direction. Therefore, marginal utility can be illustrated as the delta U over delta Y, which means the utility every next consumption of Y or X will reduce depending to your consumption amount, and every next step or of this come less and less up to the maximum point. The marginal utility of good X is the additional a little more of X when the consumption, all the other goods in the consumer basket remain constant. This means then delta U over delta X, if Y is holding constant, then marginal utility of X is supposed to be delta U divided to delta X is then of course depending to the change in the X. As much as you are changing X, then it's of course going to be increased. Suppose Y is constant, because if you have two goods of basket, then you have to concentrate only to the X changes. And if we are concentrating to the Y, then the marginal utility of Y, then the marginal utility of Y will be then of course delta U over delta Y, which means the delta U changing the utility increase or decreasing depending to your consumption and of course level will be divided to the delta Y, which is going to be the every next consumption added to your basket will then increase and enlarge your utility, or of course decreasing amount of increase is subjected here. The marginal utility of X is the slope of the utility function with respect to X. As you know, it is of course at the same time when you are taking 2 points of any line, then you have this of course slope. The principle of the diminishing marginal utility is then of course the marginal utility falls as the consumer consumes more of goods. This means that as much as you are consuming more of X, the utility or its satisfaction is decreasing, amount increase up to the maximum point is the meaning of this. The marginal utility is illustrated as you know with this indifference curve. And when we are looking to this marginal utility of muffins with the weekly consumption, as you see, this diminishing marginal utility is a positive marginal utility, means like a good. Otherwise, you would get zero or perhaps negative marginal utility. It is depending totally to you how you are going to replace between X and Y towards to your preferences, and as much as you are consuming more muffins, probably its utility, as you see, it is decreasing. And as you get the first, as I said to you, for the water, the first drink for water, probably the highest satisfaction is offered, and every next consumption, as you see observing here, it is decreasing the utility but increasing the consumption. This doesn't mean that you have too much something will give you the highest satisfaction. It is, of course, the vice versa. You are not satisfying yourself when you are having this. Here is, of course, three-dimensional utility is illustrated for y, x, and utility is, of course, given in this diagram. The utility y, as you see, is supposed to be a between x and y, and the utility is 4 here, is in this illustrated. This utility is, of course, is the indifference curve for the given combination, and for x and y you can put b also, which is 4 to 4, and for c, as you are observing, x is enlarged and y is reduced, but the utility is still same as it is illustrated with two-dimensional. And as much as you are increasing, or for increasing this utility, you have to either reduce any of these good prices, or you have to increase your income for shifting your utility function to the higher level, to the utility x, sorry, say utility 6, for utility 8, or utility 10. You understand? You are following? You observe this graphic. You have seen this graphic now. You are
Yes,
seeing
sir.
this graphic. Okay, good.
Yes.
I hope it is not interrupting again. Okay, then the indifference curve, as we illustrated it for three-dimensional graphic, then we are observing similarly here, there is the indifference curve, which is, of course, depending to your budget constraint, budget line, and this budget line should be tangent to this indifference curve for getting the optimal or maximum satisfaction regarding to your preferences, isn't it? As you are observing here, the indifference curve A, B, and C points giving the similar satisfaction to the consumer regarding to his or her income capacity. And when we look to the indifference map, which is illustrated in the three-dimensional diagram, the indifference curve or map, so-called, is the bundle of two goods, let's say food and clothing, and it is, of course, changing regarding to the price changes or the income changes. As much as you are changing the price, you will have more of something X or Y, or X or Y, because if the price of any of these two goods is going to be reduced, will then, of course, shifting your preferences towards the other, or if it is increased, then of course it is reducing and increasing the others depending to your preferences. Therefore, either your income should be increased to shift your indifference curve to the upper level, to the U6, or you have to change your preferences regarding to your price changes, regarding to the market price changes of these two goods. When we look the indifference curve and maps, the indifference curve or indifference set is the set of basket of for which the consumer is in having many different preferences, means you have these similarities and you have the same satisfaction when you move along this curve. An indifference curve illustrates a set of indifference curve for consumer. It is an ordinal ranking, not cardinal, ordinal ranking. And when we are looking to the properties of this indifference curve, again, that we have done in the start of this class, the monotonicity is the indifference curve that have negative slope, which is negative because you move along this curve will reduce it. X will be reduced towards to Y, or Y will reduce towards to X. Then it's, of course, you have to reduce something to get something. Therefore, indifference curve is negatively related or proportional between these two products. And transitivity in difference curve not crossing each other, as we always mentioning this. Every indifference curve has his own properties and, of course, standards. Therefore, every indifference curve not crossing each other. And the completeness, of course, as I mentioned in the first page, each basket lies only on one indifference curve and not in others. Every basket lies on the only one indifference curve. This is the properties so-called for the uh, indifference maps. And the averages prefer to extremes. The indifference curves are both towards to the origin because it is convex to the origin, because you reduce something to get something. This is then, of course, coming from this. As much as you are reducing, let's say y, you will get always more and more x. This is why it is convex. As much as you are reducing y, x will become more and more, and as you are seeing, it is becoming probably towards to the origin where it is going to be the highest. And the monotonicity is the consumers where likes both goods is illustrated here. As I said to you, to meet monotonicity, the preference curve must be in this area. As it is, as I mentioned to you, it is downward sloping. It should be towards to the y or towards to the x-axis where the food and clothing is illustrated. And at that point where the A is supposed to be, probably is less preferred because it is not giving any different preferences regarding to this. Is then, of course, the preference curve must be in this area where it is upper part or the lower part of this A, where it is supposed to be equally distributed at that point A. And when we are moving to the monotonicity for this clothing, it cannot be thick, because if it is thick, as you see, there will be different point on this line as it is indicated on the graphic. A and B, you are seeing also this graphic, A and B, and is, of course, if indifference curve is such thick, then between A and B there is a different preferences and different let's say indifference curves, which is not realized on the same level. Therefore, if it is thick, then this will give you a different combination of goods and products, which is, of course, not at the same proportion. It cannot be thick. The utility function is, of course, can be realized differently at A and B. Therefore, you have to get this indifference curve as a line, not a thick illustrated graphic. Indifference curve cannot crossing each other, as I mentioned to you, because since you look, if you are looking to the indifference curve 1 and indifference curve 2, you are observing there is A and B is higher than A, isn't it? You are seeing this graphic. Are you able to see the graphic 25? The page 25, this slide. Then here you see this, I think,
Yes.
isn't it?
Yes.
Suppose that B preferred to A because B is higher than A. But if it is intersecting each other at C, this means the indifference curve 1 and indifference curve 2 are equal, which is not, isn't it? Because after C, it goes down the indifference curve 2. Therefore, it cannot be possible to illustrate and show this indifference curve to intersection line where C is the intersection point cannot be realized, because B preferred to A as it is illustrated in the above part, and the B indifferent to C is supposed to be, and A indifferent to C is supposed to be B indifferent to A by the transitivity, and contradiction B should be preferred to A due to monotonicity. Therefore, from this intersection point, everything will be collapsed and it will become not valid anymore, is not acceptable. When we are looking to the completeness, each basket lies on only one indifference curve. Only one indifference curve, you will always prefer on one good over the other. So you have to prefer any of these, not the both. For goods A and B, you will either prefer A over B or B over A. Therefore, you have the utility, you have the preferences. You will get more utility or satisfaction consuming one of the goods over the other. Therefore, you have to use to determine the preference given options. As it is illustrated here, the averages preferred to extremes. You cannot create this satisfaction by shifting your budget constraint where it is intersect A and B and tangent to the indifference curve. 2 at point 0.5A and 0.5B. And this is then, of course, as you are observing, indifference curve 2 is, of course, giving the highest satisfaction comparing to the indifference curve 1. Yes, please.
We cannot see the
Yes.
notes.
You are not able to see this?
No.
Really? It stops?
Yes.
Hmm. Okay, I quit and come again. Let's see. You should see now. How about now? Sometimes it's freezing. Is okay? Is okay?
Not yet.
It will come, I think, because of the distance. You will come. You are seeing now? Tell me when you see.
No.
You should see. I think somebody is
Yes.
quitting and coming. And if somebody comes and goes, it is interrupting our system. Therefore, you should stay online, not going away. You go and come, and or some collapse system may be causing us also some problem. And you are now, as I said to you, A and B is less than C, so-called the 0.5A and 0.5B, where the point C is not illustrated. Yeah, but it is C is higher than A and B, and of course, here as you are observing, A and B is less than C, also called combination of 0.5 and 0.5B and A points where it is tangent to the indifference curve 2. And in this direction, you are always preferring the combination of this C point where it is not illustrated here, which is A and B combination is 0.5 points realized, and it is always higher than A and B, and it should be tangent to the indifference curve and of course budget line together for getting the expected higher satisfaction. When you are looking to this indifference curve, which is vertical lines, the indifference curve illustrated here, the complete each line on one line, transitivity, no cross, and of course monotonic, no negative slope. The preference direction is supposed to be illustrated here, which is not, of course, usually realized. And when you are looking at the next graphic, and here we are having here the completeness, yes, the transitivity also, but monotonic is not realized because there is no negative relation. Want as much x as possible, but don't care about y, isn't it? Because we want x, but y is here is not crossing. Therefore, we don't have any preferences regarding to this direction. So same x and more y are not better off. So no monotonicity is here realized because the curve is not existing here. There is only vertical line on this indifference curve. And when you are looking to the marginal rate of substitution regarding to these lines, you are seeing the PowerPoints. You are following?
Yes, hocam.
Okay, the marginal rate of substitution, as you are understanding, it is, of course, how much you are willing to substitute or give up to get more y. If you want to give up some x to get more y, then this will then, of course, the substitution effect. We call this marginal rate of substitution, which means you have to give up some x or y to get some y or x. Vice versa, bilaterally is possible. Therefore, you have to give up x, some x to get some more y, so-called. It is the increasing good x that the consumer would require in exchange for for a decreasing good. Why? In order to leave the consumer indifference between consuming the old basket or the new basket, which means you have to give up something to get something. You understand? Because it is like this, since you don't have too much income for consuming all for your preferences and for your taste, then you have to, of course, determine between the existing options to get what and how much. And when we are looking this as a real formula, the marginal rate of substitution is equal to the delta y over delta x, which means the difference between y and x will gives us this marginal rate of substitution of this indifference curve, as you are observing in the graphic. It is the rate exchange between good x and y that does not affect the consumer's welfare, because on the indifference curve you are always having the same satisfaction or taste regarding to these preferences. And when we are looking to the indifference curve, which is illustrated below, the A and B, as I mentioned before, is of course offering the similar satisfaction but with different combination of x and y, which is illustrated on the graphic as A and B, where the indifference curve is tangent at A and B to the budget constraint at different points. The budget constraint is of course here, or budget line is of course here, illustrating your income, and your income can be combined or combined between x and y, either at B or A, which is no matter and not of course causing you any problem. You have the similar satisfaction at that level. The following indifference curve, what is the marginal rate of substitution between x and y, is supposed to be illustrated here, as I mentioned to you, the indifference curve 1, the indifference curve uh, uh, 2, and indifference curve C, 3, sorry, are of course representing the higher level of satisfaction, because this indifference curve is a line, is a linear line, and it can be illustrated with the level of satisfaction which is increasingly realized as much as you are shifting towards away from the origin. And when we are looking here, if the utility function is equal to x multiplied y, the graphic will be as it is given here, as you can give the numbers to x and y, and you will see the equation, how it is changing. If we give, for example, x 2 and 5, y is 5 and x 2, then multiplied will become, if your utility is 10 supposed to be, the utility is amount 10. If you give 10, as it is given in the example, then the other option can be 5 multiplied to 2. Then you can replace this either towards to the y or towards to the x, which is, in the first case, y is increasing, and the second case, the amount is increasing, but the satisfaction level is not changing. It is stay intact, and it is becoming equally distributed on this indifference curve. And if the indifference curve increasing to the 20, then you are understanding, then you have probably the income increase, because we didn't put already the budget constraint on this graphic, or you have some other preferences because of the price changing, probably either x or y prices is reduced. And when it is realized in this direction, then you are understanding, you are following this graphic. Yes, I think you see.
Yes.
Okay, then here, as I mentioned to you, indifference curve 20, which is the utility is 20, is higher than indifference curve or utility function, which is 10. In this direction, you are expecting either the price changes is realized, which means either x or y is reduced, or the income, the budget line, which is not on this graphic, is illustrated, is expected to be increased, maybe 10% increase or 20% increase, and shift this utility function to the upper level. And when you are looking to this marginal utility and marginal rate of substitution, we are having here this equation. The marginal utility of x, which is given in the graphic, is supposed to be delta x multiplied and plus marginal utility of y. You are seeing these equations, is the multiplied with delta y is supposed to be equal to 0 along this indifference curve. And since it is so, if we replace this equation cross multiplying or dividing each other, if you're dividing marginal utility of x to each other, and you will get this equation, marginal utility of x over marginal utility of y is equal to delta y over delta x, isn't it? Then this will then gives you the marginal rate of substitution of x to y, which is the utility function between x and y. And then we are putting this delta u as the derivation of this graphic. The derivation of this graphic or this equation will gives you the delta u over delta x multiplied delta x plus delta u over delta x multiplied delta y is equal to 0, which is the derivation illustration. And when you take this derivation, then you will have the, of course, once again, this marginal rate of substitution as minus delta y over delta x is equal to delta u over delta x divided to delta u over delta y. Therefore, this can be written in this direction as you are observing. It is not given anymore. I stop here, I think. Then of course, the marginal rate of substitution is then, of course, can be illustrated with this equation, which we are going to use for estimating the differences or derivation of the delta u over delta x can be equal to delta u over delta y after we are going to represent this as marginal utility of x over marginal utility of y, which is the upper part, and marginal utility of x over marginal utility of y is equal to delta y over delta x, which is going to be, of course, summarized after you are going to estimate with the mathematical representation. Then you will have this marginal utility of x is equal over marginal utility of y is equal to delta y over delta x, which is, of course, negative form represented. The marginal utility and marginal rate of substitution, of course, is the positive. Marginal utility implies the indifference curve has a negative slope, is monotonicity, of course, and diminishing marginal utility implies the difference curve, the indifference curve, sorry, are convex to the origin, because since it is convex, as much as you are reducing the y, you will get more x. This is becoming of this convex position of the graphic. And here again, I put the example for you. As of course not numerical, the u is supposed to be ax square plus by square is supposed to be given. And when you want to get the marginal utility for x, then this will be okay. This will be, sorry, will be equal to 2ax, isn't it? Then you are getting the derivation. Delta u over delta x gives you the 2ax, and when you are getting the marginal utility of, which is the derivation of delta y over delta x, then is equal to 2by. You understand here? You got this example? Is clear this example for you? You listening me? You see this example?
Yes, we can see it.
Okay. The marginal rate. I will repeat it. Okay. U as a utility function is given here is equal to x power of 2 plus by power of 2 is then, of course, equally distributed. The marginal utility for x is as the delta y, delta u over delta x is the derivation of this equation for the x, then will be 2ax when you are getting the derivation, and for the y, when you are getting this marginal utility for y, it is of course again the derivation for delta u over delta x, delta y, sorry. This will be then equal to 2b, where b is supposed to be positive intercept or coefficient, and marginal rate of substitution x to y is then of course represented as marginal utility x divided to marginal utility y is equal to ax to by. Then this is then equal to ax over by. The marginal utility are positive for positive x and y, which is supposed to be, and marginal utility of x increases in x, and marginal utility of y increases in y, as it is given in this example. Therefore, implication of this indifference curve are negatively sloped both out from the origin, and preference direction is up and right, and indifference curve intersect the axis. Okay, let me go further. This indifference curve with increasing marginal rate of x to y substitution, then if the marginal rate of x to y is higher at basket H than at basket G, where we put this graphic before, then the slope of indifference curve U1 will be more negative, steeper at H than at curve, sorry, curve U1 will be more negative, steeper at H than at G. Thus, with increasing marginal rate of substitution x to y, the indifference curve will be both away from the origin, which means you are increasing and enlarging this indifference curve towards away from the origin. If we are giving here an example for being able to understand this, let's see this example. Consider what happens when a utility function has an increasing marginal rate of substitution. Problem: suppose a consumer's preferences between two goods x and y represented the utility function, which is given u is equal to ax2 and b plus by, where a and b is supposed to be positive intercept. For this utility function, marginal utility x is 2ax, of course this is the power of, and marginal utility y is then the 2b power of, which we done it before, and the marginal rate of x and y is increasing as it is in the former example. The solution: since both marginal utility of x and marginal utility of y are positive, indifference curve will be negatively sloped, because it is so. You are increasing something and of course reducing something. This means that as an amount of x is increases along an indifference curve, y must decrease compared to x as an amount more. We know that marginal rate of substitution x to y is equal to marginal utility of x divided to marginal utility of y is equal to 2ax over 2by. Therefore, this means that as we move along the indifference curve, by increasing and decreasing y, marginal rate of x to y will increase. So we have an increasing marginal rate of substitution of x for y. In this case, then we will illustrate indifference curve for this utility function with increasing marginal rate of x to y. They all away from the origin, which is concave, of course. Now, then let's see this. Of course, you can follow this in your book with this problem 310 and 311, which is, of course, good. You understand what they're doing. And this is concave because increasing marginal rate of substitution is supposed to be realized between x and y. If the marginal rate of x to y is the higher at basket H, then at the basket G, the slope of the indifference curve U1 will be more negative, isn't it? And of course, it is becoming more steeper, because as you see, it is steeper means more vertical. And when you are looking to the G is more horizontal. Therefore, G is supposed to be more horizontal and H will be more vertical. Thus, with increasing marginal rate of x to y, the indifference curve will be both away from the origin as it is opposite direction illustrated. Not it is convex, it is concave now, isn't it? As you are observing here, because it is increasing differences realized between x and y. And when we are looking to this example, you see if the utility function is now x multiplied y is the power of 1 over 2, which is 0.5, then the marginal utility function can be illustrated for x and y as follow. Marginal utility x is equal to y over, or y power of 0.5 is divided to 2x 0.5. Then the marginal utility of this is the derivation that we are taking, delta u over delta x. If you don't know how it is going to be taken, you write me mail, then I will show you how the derivations realized. And the marginal utility of y x, of course, is the illustration of the delta u over delta y, which means x power of 0.5 is divided to 2y 0.5 is better. Is question is more better for this case is satisfied or no? Since marginal utility are positive for both, then yes, we may say, and are the marginal utility for x and y is diminishing is question. Yes, we have to answer for the A, because x is increasing for y constant and mu x is falling. Since y is a numerator and x is the denominator, then what is happening? Because it is increasing, isn't it? If you are increasing y, this will cause higher marginal utility for the marginality of x. Therefore, you have to see this because the position of numerator of y and denominator for the x is of course causing this reduction. We are looking to the what is the marginal rate of substitution of x to y, is then of course marginal rate of x to y is equal to marginal utility of x over marginal utility of y is equal to y over y power of 0.2 0.5 sorry is divided to 2x 0.5, then will be divided, because we are taking this marginal utility functions for x and y, then x power of 0.5 will be divided to 2y 0.5, then this term will be summarized as y over x, as you are observing here in this example. And do the inference curve intersect the axes, then the value of x is 0 and y is 0. This is of course inconsistent with a positive level of utility, can be said, because when you are dividing it to 0, or when you divide 0 to something, then this of course becomes 0. Upsala. Then we move to the graphical illustration for this. As you are seeing, it is of course, it is now convex to the origin and it is moving towards the origin. And graphing inference curve is of course, as I mentioned to you, as much as you go up, you are enlarging it and increasing its satisfaction. When we are concentrating to the Cobb-Douglas, you know Cobb-Douglas population, I think, x power of alpha, y power of beta is the, of course, Cobb-Douglas equation we're using for the production function. Here we are illustrating this as the utility. Then utility is supposed to be a multiplied, a is a coefficient here, multiplied with x power of alpha, multiplied with y power of beta. And where here it is supposed to be a and b is equal to 1, and a and b is a positive constant. And since you know, if it is a and b equal to 1, this means there is of course constant relationship. If it is higher, then there is increasing relationship for the Cobb-Douglas I am talking about. And if it is a alpha plus beta is less than 1, then this is of course decreasing function, and decreasing amount of increase realized in this direction. And marginal utility of x is equal to alpha multiplied with the a x alpha minus, because we are taking the derivation here as you are observing, alpha minus 1 is multiplied with y beta, and marginal utility of y, the derivation delta u over delta y, then is of course beta R is of course should be larger, capital, is of course x alpha y beta minus power of beta minus 1 is the equation for this um, graphic. Here A is a little bit small, it should be larger. And the marginal rate of substitution for x to y then is of course delta y over delta, sorry, beta x is illustrated. The marginal rate of substitution only depends on the ratio of x and y, not on the total amount of x and y, of course. So indifference curve for different levels of utility look identical to each other, no matter how far away from the origin they are moving. Therefore, when we are illustrating this, it is of course dependent to the substitution of complete effects. When we are looking at perfect substitution effect, the u is equal to ax plus by. Very important when we again taking this marginal utility of x, which means delta u over delta x is equal to a when you did the derivation for x, and we are taking this delta u over y, so delta uy, then this of course the equation, this means the delta u over delta y, which is the marginal utility derivation, is of course giving here the b. The marginal rate of substitution for x for y is equal to then a over b, then so that the 1 unit of x is equal to b over a unit of y everywhere. It is supposed to be constant marginal rate of substitution realized because there is two intercept here which we are calculating or estimating for this, which means one changing one unit equally change to the others. Marginal rate of substitution only depends on the ratio of a and b, not on the total amount of x and y. Therefore, as much as you change the coefficient, the amount of x and y will be changed. Therefore, depending to your coefficient which you are going to calculate or estimate in this equation, or which is going to be put in this equation. So indifference for levels of utility look identical to each other, no matter how far away from the origin they are. And as you are observing here, the perfect substitute is a linear equation and linear graphic. As you see here, it is supposed to be the next indifference curve 1, indifference curve 2, and indifference curve 3 is of course the slope is the intercept only minus a over b, which is of course a line, not a curve, not nonlinear. It is a linear equation, a linear curve here illustrated. You are observing this graphic? Hope so. Okay, the perfect complements, of course, after the substitution, then we may put here again this equation. U is equal to minimum alpha multiplied x and beta multiplied y, where a and alpha and beta are positive constant, and minimum means take the smaller of two constants, which means you want 8 ounces of coffee with 1 ounce of cream is the coefficient x and 8y, where x is the cream and y is the coffee. So the coefficient will be then of course replaced with this given example, x over y. Then this is then of course represented with alpha over b is equal to 1 over 8 is the fixed proportion, where the marginal rate of substitution is 0 or infinite or undefined. And it can be illustrated with this direction, which is perfectly complement. We are concentrating this as much as you are increasing y is this should be of course dependent to this complement effect. You have to increase either if it is going to be enlarged and decrease. Therefore, complement graphic is of course illustrated as a 90-degree line, can we say. The perfect complement therefore then is shifting away or moving away from the origin as much as you are increasing this indifference curve combination regarding to your price changes or regarding to your income changes, where the alpha and beta as an intercept is shifting and of course enlarging it as much as possible. And quasi-linear preferences, which is non-linear, then of course here we are giving again the u is equal to vx plus ay, where a is a positive constant and marginal utility of x supposed to be is the vector v. X is equal to delta v x over delta x, then delta v over delta x, where delta small and marginal utility of y is equal to a. The only thing that determines your personal trade-off between x and y is how much x you have and how much you are going to enlarge it, because the only variable here that you are going to concentrate is, of course, is supposed to be concentrated to the x. And when you are representing this quasi-linear, as you see, the affecting and changing, the marginal restitution diminishes at the quantity of x increase, but does not depend on the quantity of y, as I mentioned to you, because it is directly concentrated to the x. And the quasi-linear preferences consumption of beverages is illustrated as the indifference curve as the upper level because of this intersects change. Of course, the indifference curve is shifting upper level, where your budget line is also shifted and of course enlarged depending to your price or income changes. The income indifference curve has the same slope, but it is of course a vertical line for the y is subjected. The summarized so not exactly the summarize of this class, but can be given as the consumer preferences without any restriction imposed by the budget, which means the indifference curve is directly related with your budget line, with your budget constraint, and of course your combination of your basket of goods, where x and y here is as a scenario illustrated. Therefore, you are exercising every budget line on this scenario. And minimal ordinal utility, as I mentioned to you, is subjected here. Therefore, you exercise and introduce, you become introduced with this utility function, and budget line, and of course demand, and of course consumer preferences subjected. In this direction, you learn how the utility is changing and affecting our preferences, and how the preferences affect changing depending totally to your expectation of combination. Therefore, in this lecture, we have done this and combined this utility function with the demand curve. And the next lecture, we will start to exercise more utility and more estimation on the utility function, where it is more comprehensively given to you. If you have any question, you will ask me. If you don't, then I will stop this class here, and we go to the next class after exam. Do you have any question? If you have any question, please ask me. If you don't, then
No.
Which chapters is going to be in the test?
I said to you, you are going to concentrate to the first chapter, the demand that I given to you, supply demand, choice, demand theory that I have given to you.
Demand theory and what?
Three chapters.
Okay.
I have given to you the first chapter, these tools. You remember?
Okay, sir. Thank you.
And then supply demand curve, the movements on the supply demand and how it is affecting and changing the demand curve. And then I gave you the theory of demand last lecture. And today I gave you of utility or choice of demand picture after the test if you are studying. But mostly I will concentrate to these PowerPoints and of course the book that I have advised you to use for your classes. The Bräutigams, sorry, these Kabaus world, sorry, this Bräutigams books, you have to concentrate it for the micro. You can use some others, but Bräutigams book is probably the most we are using in this class because
Thank
it
you
is
very
very
much, sir.
comprehensively given to you. Yes?
Thank you.
If you don't have any question, stop this. Is clear? If you don't have, I stop. Okay, see you then next week on Wednesday at 10 o'clock. Don't forget to come to the class because we will have the test. Okay? Is it
Sir,
clear?
for the test, I want to
Yes,
Yes.
sir.
ask a question. Like when you show the questions on the PowerPoint, are we going to be
Yes.
writing on paper or
Yes. No, you write all of us and take the picture, and after finishing this exam, you send it to me.
okay?
Or you send email me this after the class finish, after 1 hour maximum, after an hour or after half an hour, or online you can send me to WhatsApp. But mail is preferred. Okay, you send me all together. I think in a mail is better. Okay, this is the best
Okay.
way. If you wait and send it to me after an hours in the night is not accepted. You have to send it after an hour, please, because this is exam. Is clear?
Yes, it's clear.
Is okay?
Yes.
Okay, then see you then. I'm finishing down the class. Okay, bye bye. See you then. Bye bye.